Welcome to the last of these videos for this week on air pollution and control. What we're going to look at this time is some of the effects. Well, but firstly, there's a little bit of chemistry which I think you should be aware of. We talked last time about sulfur gases, sulfur dioxide, sulfur trioxide, and nitrogen oxides and acid rain. So I've just put here the chemistry. So clearly sulfur and oxygen combine to form sulfur dioxide, and that's further oxidized to sulfur trioxide, which when combined with water gives you your sulfuric acid, which is acid rain. And the same sort of thing happens with nitrogen. In the presence of ozone, you get nitric acid. And the effects can be quite dramatic. Round about the turn of last century, in the early part of the 1900s, Queenstown looked like this. In fact, this is a reasonably recent photograph. What was happening, that the copper that was mined underground was smelted, and that produced a considerable amount of mainly sulfuric acid, and the result was that all the trees disappeared, and you have this lunar landscape looking like the moon coming into Queenstown. That's the road coming in from Hobart down the side of Mount Lyell. I've given you the link to a video you can watch there. One of the nasties is photochemical smog, and that can be deadly. The prime example is the Great Smog of London, and that killed very many people, and that was because a lot of coal was being burnt for domestic heating. And so I've got a slide here which shows the formation of photochemical smog. So it starts off with nitrogen oxides and hydrocarbons, and then, as I mentioned earlier, in the presence of light, UV light, so the hole in the ozone layer has an effect here, because that means that there's more ozone O3 produced, and that is one of the factors in the production of photochemical smog. And there's an even better diagram here showing the cycle. It mentions nitric oxide, NO, and nitrogen dioxide, NO2, and they're generally referred to as NOx, NOx. Again, there's another link to a video, and you can see a history of the Greater London smog in 1952 it happened. So there are a couple of other factors to consider. There's the hole in the ozone layer, so that just depletes some of the ozone in the atmosphere. But the effect of that is to increase the UV ultraviolet, which we see at the Earth's surface. Here are some of the substances that can deplete ozone from the ozone layer. And you might remember, or you might have seen, that refrigerants, a number of them are now not being used because of their effect on the ozone layer. And so we limit halons, we limit other chemicals such as carbon tetrachloride, and particularly the hydrofluorocarbons, which we know are instrumental in depleting the ozone layer. And there's a little quote from the TripAdvisor here, warning people who come to Tasmania that you can get quite severely burnt in about 15 minutes without some protection at certain times of the year. So I'm not going to go into global warming. It's an enormous subject. It's quite relevant. And as I say, there's absolutely no possibility of even scratching the surface of this issue. It's still an issue. But if you want to look at some interesting aspects, I've given you 2 links there to support the contention that global warming is real. And there's also the question of whether it is natural or man-made. And I've also given you 3 references to the other side of the argument. So finally, let's look at a few other matters like indoor air pollution. And I just grabbed a few slides here from the web, and just a few of the fairly obvious ones: kerosene heaters, gas stove, gas heaters, exhaust from the garage or the fireplace will contribute to indoor air pollution. And here are a few more. So you can have gases eliminated from particle boards, plywood, paneling, paints particularly. And some older houses actually had lead-based paints. So you need to be very careful if you're renovating an older house that you don't start trying to remove the lead-based paints with a torch and scraper, because you will be very, very quickly overcome with the fumes. And there are some of the other little nasties: dust mites, fur, animal fur, dog fur, cat fur. And just to, you'll see advertisements on the television about how you should be cleaning your mattresses and carpets and so on to get rid of these little beggars. And then some people are quite allergic to pollen, and there are some examples there. And of course, we all know about viruses. And I've just put in dropped in a photograph of an air conditioner, and there's some interesting research happening at Melbourne University. I think it is right now, it might be Monash, but they've worked out that if you use a commercial air purifier, one that just pulls the air in through a filter, like an air conditioner, as long as the filter is sufficiently fine, you can get rid of 98% of the viruses, because they're aerosols. Well, the viruses aren't aerosols, but they're contained in aerosols, and not all that expensive. You know, $100 worth of room air purifier can get rid of quite a lot of get rid of most of the aerosols. So that's some interesting work that's happening right now. Pretty well, finally, let's have a look. No, not finally. There's one to come after this: asbestos. and that is pretty nasty. And it's also quite ubiquitous in that asbestos was used for building up till about, I don't know, the end of the last century, when people started to get, authorities started to realise that it was quite serious, the problems that the asbestos can cause, mesothelioma, people were dying from it. And when I built my boat in the, my fiberglass boat in the early 70s, 80s, forget now, that was full of asbestos. Asbestos is a very good filler for fiberglass. Can't use it anymore now, but so I would be a candidate for mesothelioma. Hasn't happened, fortunately. So there's something to read there when you get a chance. And one which you don't hear much about is the gas radon, which is carcinogenic, and that's contained in dolerite and other rocks, igneous rocks, and it can be concentrated in a house. And just recently, a number of dwellings, not here, but on the mainland, were condemned because of high radon levels detected in the dwellings. And finally, tobacco smoke. And it says the three most significant indoor air pollutants in Australia are asbestos fibres, radon gas, and second-hand tobacco smokes. So I'm quite pleased to report that the university now is a smoke-free zone. And there are some statistics there which will probably shock you, and they should prevent you from, well, they should lead you to a conclusion that smoking is not very good for you. But the more important thing is that other people can be hurt by inhaling secondhand cigarette smoke. So there are some statistics there. I'll leave you to read through the nasties. There are a few threshold concepts to think about: visible and invisible pollutants. Like you can see smoke, you can't see carbon monoxide particularly. And the difference between what is detectable and what is hazardous, and then local versus national versus global. All right, so if you've got this far, thank you very much. You've done well. We'll be going through some of the threshold concepts, the important points in the class on Wednesday morning, I believe it is. And I'm hoping that, as I say, if you've got this far, you've done very well. If you haven't, well, after the lecture after the class on Wednesday, you might have now reached this point. So again, thank you for your attention, and I'll see you in class next week.